In the previous video, we finished off our discussions about inheritance. So now it's time for the challenge to solidify your understanding of what inheritance is. But before I do that, I just want to talk about that all classes in Java inherit from automatically. I briefly alluded to that in the previous videos. But what actually happens though, even if you're not typing the keyword to extend a class, which we've shown in the previous video, the use of the extends keyword, the class is automatically inheriting from a Java supplied class called the object class. And you can see that by opening up your generate command. If you go to override methods, you can see when I've done that, select methods to override or to implement. You can see here these are all methods. The M stands for method, and these are all methods that are inherited from java.lang.object, which is a class that classes that you create are automatically extend. So it's equivalent essentially to typing extends object, java.lang.object, so you can see there, and we can go and have a look at that, and you can see class object is the root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement the methods of this class. That's really important to know that this happens automatically. This is the actual source code for the object class, which is inherited automatically from when you create other classes. So you can see that we'll go through some of these methods. We get a hash code, an equal, so it's a comparison determining one type of object against another. There's also a toString, which we'll be using to later, which is a string. It's just a way to return a string representation of a specific object. So I won't go into any more now, but the main point I want to really pass on at the moment is, even though your classes, when you're creating new ones, you aren't actually typing an extends object, they are automatically extended by Java. And that's it's an interesting thing to realize, and that's just the way that Java do implement. Okay, so I'll just undo those changes. Okay, so let's talk a bit now about the challenge for inheritance. Okay, so here is your challenge. You want to start with a base class, which is a vehicle. Then you want to create a car class that inherits from that base vehicle class. Then finally, you want to create a third class, which is for a specific type of car that actually inherits from the car class. Now, you'll be wanting to, in these classes, you should be able to handle steering, changing gears, and moving, speed in other words. And you need to decide where to put the appropriate state and behaviors. Of course, that is the fields and methods that are appropriate for each class. And you'll want to create some unique behavior that is specific to that final class that inherits from the car class as well. So have a go at doing that challenge. This will really help your understanding of what inheritance is. And pause the video now, go away and do that. And once you've had enough, or once you've got a solution and you want to compare the solution to what I've come up with, come back and we'll go through that. Okay, how did you get on? Did you figure it out? And bearing in mind there isn't only one answer to this, there's quite a few different ways to implement this. But the answer I'm going to come up with is to start with the vehicle class. So I'm going to create a new class and call it vehicle. And with that vehicle class, I'm going to have two fields. I'm going to have private and string name, the name of the vehicle, because of course all vehicles have got a name. And I'm also going to go with a size. You could have some other generic characteristics here, so long as it's specific to a generic vehicle, and that would be fine. There'd be no problems there. We also want to have a constructor for both those fields, so we can initialize our object. The other thing that we're going to have here is also two other fields which deal with the current velocity, current speed in other words, and also the current direction. And we want the velocity so that we can determine the speed, figure out how fast the vehicle is going, and also the direction where it's pointed to at the moment. So I'm going to do private int current velocity and private int current direction. Now, unlike the first two fields that I've defined, what we're going to do here is when we're creating a new instance of the vehicle class, in other words creating a new object, we're just going to initialize velocity and current direction to 0. So this dot current velocity is equal to 0. This dot current direction, current direction equals 0. So next we talked about, going back to our description, we're able to handle steering, changing gears and moving. Well, of course, in our vehicle class, we haven't got a concept of gears. And the reason for that is not all vehicles have gears. So it wouldn't be appropriate to put gears in here. But the other thing was moving. And moving is, of course, something that all vehicles do. They do move and they can be pointed in a certain direction. So we need to handle that in this class. So I'm going to first create a public method called steer. It's going to take a parameter for the direction. And what I'm going to do is actually add to whatever's been sent to that method to the current direction. So in other words, it's a mechanism for steering. So I'm going to call that public void steer int direction. And I'm going to put current, this dot current direction plus equals direction. Then I'm going to do some system output to put vehicle dot steer. And I'm going to put steering at, put the current direction. And we'll call it degrees, but it might just be an angle or whatever it is, but we're just going to call it degrees. So that's our steering method, which again applies to all vehicles. We're also going to create another method. I'm going to call that move, and I'm going to accept two parameters, the velocity and the direction. So I'm going to put public void move int velocity and int direction. I'm going to put current velocity equals velocity, current direction equals direction. And put an output message, vehicle.move, moving at plus current velocity in direction, current direction. And unlike the steer method, what we're doing here is we're actually setting the velocity and direction to the specific number. With the steer, the way we've set that up is we're allowing you to change relative to the current position. So we're storing the current position of the current direction, enabling you to move relative to that. Whereas the move method, we're actually allowing you just to effectively change the velocity and the direction. No right or wrong here, it's just my implementation for that. And we also want to do a getter and setter for a few of these fields. So I'm going to just, probably for speed wise, I'm just going to select that and choose a getter for all the fields. So that's our vehicle class. So next we want to create the car class. And we want to obviously extend or inherit from that vehicle class. So I'm going to create a new class, call it car. And of course we're going to extend or inherit from vehicle. And obviously it'll want us to create a constructor. But before we do that, we want to create the unique fields for a car. Firstly, we're going to define the number of wheels because not all vehicles have wheels. For example, some boats are vehicles and they don't have wheels. And we're going to define doors, which are unique to a car, the number of doors. Int gears, as to the number of gears that are present in a car, because all cars do have gears. It's a different number, of course. We're also going to use a variable is manual. And that's a true or false as to whether it's got a manual or an automatic gearbox. And we're going to store another variable called current gear. And if you recall, we talked about that in the vehicle class. Because not all vehicles have gears, we've decided to create a field called current gear and put that in the car class. That's going to be our current gear. So that's the current gear that the car is in at this point, at any point in time. So let's create the constructor. And the constructor is going to initialize all of these. But you notice it also put some extra code in for us, which was the two parameters, the string for the name and the string for the size, which are going to initialize our vehicle class as well. And that's IntelliJ doing that work for us, which is very nice. Now, what I'm going to do though is change the last parameter for the gear, the current gear. We don't actually want that as the constructor parameter. And the reason is we're going to assume that when we create a new object, we're going to set that to 1 to be in first gear. So now we need a few other methods here. What we need is the ability to change the gear. We need the ability to change velocity of the vehicle. We're going to add a method to stop, and we also need to be able to steer as well. So So let's start by creating a setter. We're going to create a setter for the current gear. So I'm going to select current gear, and I'm going to put car.set current gear, changed to this.current gear plus gear. So that's just a standard setter to change to the current gear whenever we need to do that. And what we could do, because that's a setter, probably, now normally the convention is to use the word set, but in this case it might be better to actually rename that and to call that change gear. We don't have to use set current gear. In this case we're going to just call it change gear, which probably reads a little bit better and makes more sense as to what we're trying to do there, because this is going to be a function that we're going to be able to call. So next we want the ability to change the velocity of the vehicle. So we could just leave it, so we could just have no function here and just call the basic function that we've set for move here, in which case that would work and work fine without any problem. And when you're extending and implementing classes, you have got a choice as to whether you want to use that low-level function or override it. In this case, what I'm going to do, I'm going to create another method, call it change velocity, which takes two parameters, which is the velocity, or we're going to call it speed here, and the direction. And that's going to call the move method, move, speed, direction. Like so. So that's change velocity. And the reason I'm doing that is at some future point we might want to have some other mechanisms in here with the velocity. For example, to test the maximum speed of the vehicle or some other conditions that are unique to a car as opposed to a vehicle. But at this stage we're just going to be calling the vehicle move method. The next method I'm going to have is the stop method. This is the ability to stop. So you could argue that all vehicles need to have a mechanism to stop. And to that end, we should probably create a public method for stop. So public void stop, and I'm creating that in the vehicle class. So stop. And all it's going to do is put the current velocity, set that to 0. And that's all the stop does. It basically stops it. It doesn't try and reposition the direction or anything of that nature. It just purely stops the vehicle. But in terms of stopping for a car, what we want to do is we want to implement the method, but we want to override it. So I'm going to override the stop method for the vehicle. So I'm going to select stop. So what I'm going to do, I'm not going to call the super method yet. So actually what I'll do for now is I'll delete this method because we don't really need to override it for now. For this basic car class, it's enough for us to know that we've got a stop, which will set the velocity to 0. When we get to using the next class, which will be the class that inherits from car class, that's when we'll add some more functionality to the stop. And with steering, the same applies. We don't need to change anything in the car class because we're going to just pass that on to the vehicle class. Okay, so you can see now we've implemented the car class. So let's now move on to the next class, which is going to be a specific type of car that extends from the car class. So I'm going to create a new class. I'm going to call it Outlander, which is a Mitsubishi four-wheel drive. So I'm going to create that, and I'm going to do extends car. Now what I'm going to do is assume, so obviously we're extending from car, so it's got all now the unique characteristics from the car and the vehicle. I'm going to add one private field, which I'm going to put road service. The number of months of road service that are available for this type of vehicle. Next, I'm going to create a public constructor. I'm going to initialize the road service, and you'll find it automatically initializes all these other fields for us as well. But what we can do with some of these parameters is we can change them. For example, for the Outlander, we don't need to have that as a parameter because we're going to presume, because this is an Outlander class, we know that it's the Outlander. So we're going to use that in our constructor. We're going to just pass Outlander. And for the size, we're going to go with four-wheel drive. So we also don't need that as a parameter. So I'm going to actually change those from the the Outlander parameters. And we're left only with the wheels, the doors, the gears, whether it's manual, and the road service. And actually, as it turns out, all of those parameters there, the wheels, the doors, the gears, and the manual, because we're defining now the actual type of car, we shouldn't really have those as parameters. What we want to do is just hard code those, for want of a better term, in the constructor setting. Now, of course, you could still make it optional if there were multiple types of Outlanders, which there are in real terms, but to keep things simple, we're going to presume there's only one type of Outlander, and we know ahead of time the number of wheels and doors and gears and so forth. So what I'm going to do there is put the number of wheels to be 5, including the spare, 5 doors, including the rear door, the 6 speed, and we're going to put is manual, we're going to set that to false because it's actually an automatic. So consequently, now that I've done that, I can actually delete those from the constructor, as you can see there. So we're left now to create a new Outlander, which of course is extending from the car class. We really only need to pass one parameter, which is the road service, the number of months that this vehicle has got for road service. The new cars, with Mitsubishi cars, they give you so many months of free roadside service if you ever break down. So what we're defining is how many months this vehicle has got. All right, I'm going to pause the video here. We'll come back in the next one and continue on with the solution to the challenge, with the solution to the inheritance challenge.